Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. Now this tutorial is about regular expression possessive quantifiers. I'm going to open up my web browser to my website, javacjava.com, select Menu and Regex Tutorials. I'm going to scroll down here to Regex Possessive Quantifiers tutorial. Excuse me. There are three different groupings of quantifiers: greedy, reluctant, and possessive. Now this tutorial is all about possessive quantifiers. Possessive quantifiers are perhaps the most rarely used of all the quantifiers. In my Regex Greedy Quantifiers tutorial, we learned that greedy quantifiers instruct the matcher to match as many instances of its quantified token and return the largest possible string value. Now in my Regex Reluctant Quantifiers tutorial, we learned that reluctant quantifiers instruct the matcher to match each individual instance of a quantified token and return the smallest possible string value. Now once again, the difference between possessive, reluctant, and greedy quantifiers are not always obvious. Possessive quantifiers function just like greedy quantifiers, only there is just one simple rule to remember: they never backtrack. Never backtrack. That's all we need to remember. The only reason I can possibly think of to use possessive quantifiers is to increase the speed of a regex search in certain situations. Now, with the speed of today's computers, I'm not really sure it matters unless you're running a regex on a database with millions of records. However, if you're running the regex against something like a text box validation on a website or application, I recommend simply using a greedy quantifier. The syntax for possessive quantifiers is the same as greedy quantifiers, only you will simply tack a plus meta character onto the greedy quantifier to turn it into a possessive quantifier, right? So question mark plus for once or not at all, asterisk plus or star plus for 0 or more times, plus plus for 1 or more times, and then of course the exactly, the at least, and the at least but not more. So let's go ahead and come down here, highlight all the source code, and hit Control-C to copy, and right-click and select copy, or right-click and select copy, either or. I'm going to go ahead and move my browser off screen here, and I've got a shortcut to the command prompt on my desktop, but if you don't, I'll create one real fast by right-clicking, selecting New, Shortcut, C and D, Next, and Finish. It's just that easy. Let's go and open that up. If you're new to my tutorials, type in javac, which is a Java compiler command. You should see all the stuff scroll by. However, if you receive an error message, watch my tutorial on installing and configuring the Java development kit. You want to make sure you get that done properly before continuing. CLS to clear the screen, CD space /, CD will change directory to the root, and we're going to make a directory there called Java, and I already have that folder, but if you don't, I'll create one for you. I'll make another directory here, and I'm just going to call this one Regex Possessive Quantifiers. Okay, and I'll change directories to that, and I'm on Notepad Regex Possessive Quantifiers.java. Alright, it's going to name my source code file, also known as a compilation unit, and it's going to paste that source code in there. Come up here and save right away. Very simple. We've got the importing the Java util regex package, single class, main method entry point, using the same static void display find message that I did in my last two tutorials on quantifiers there. And basically I'm applying all of the possessive quantifiers to the exact same thing that we had going on before up there. So let's come up here and save this. and let's use Javac to compile this. Let's clear our screen, Java to run it. And so up at top here, you can see that we get the exact same results there. COLO, and then basically we got the character U, right? And then our possessive quantifier, which question mark, right, is, pull this over, right? Once or not at all, right? So it found color in, is that a coloring book? Because the U is in there not at all. It found a same regular expression over here because it's in there once, okay? So we get all this stuff is pretty much works the same as greedy quantifiers and reluctant ones there too as well. All right, so it really starts to become obvious when we create a little bit more detailed or more complicated, I should say. It's not exactly the best word for it, but more thorough or expand our regex there. So in this particular one here, I'm going with that same, I like happy large dogs and happy small dogs. And of course we got happy and dogs here, happy and dogs there. Only difference is we got a large and a small in between there. So our regular expression on a greedy quantifier will find everything, happy, and then basically dot, of course, is a wildcard symbol, which represents all characters except for a new line. Okay? And then, of course, we've got the asterisk there, which is a greedy quantifier for 0 or more times. So the way this works, we know it's going to return this string right here, but how exactly does it work? Well, it comes over and it finds a first part of our regular expression, which is happy. Then the dot star tells it to go ahead and basically consume all the rest of the string here. Read it all in there, right? And then what it does is it does what's called backtracking, okay? So after it consumes all the rest of this, it backtracks until it can actually says, oh, okay, well, for example, backtrack one character. Well, that is a exclamation mark, and I am looking for basically the D next, right? I'm looking for a D, this single D character here, right? So this backs up and it says, no, there's no D there, no D there, no D there. Oh, hey, look at that. I found a D. Now I need to find an O, a G, and an S, right? An O, G, and an S. Okay? So at this point in time, we've started it out there. It goes all the way to the ends. It finds its D. It matches the O, G, and S, and it says, okay, here is what I'm going to return back. Okay? And that's basically the way that works on a greedy quantifier there. Now, the reluctant quantifier here, right, same regex, only it's reluctant here, right, basically says, okay, we're going to start at the happy there, and then we're going to find the first, we're going to go with any character, right, wildcard character, until we find a D, right? So it starts off happy, and then it goes, all right, we're looking for a D, oh, found a D, yay! And then we're looking for an O and a G and an S too as well, right? So there's our D and then O, G, S, and it says, okay, we're done. This is the smallest possible string that I'm going to return. So it goes ahead and returns back that happy large dogs right there, right? Now, when we invoke the find method again, it checks and says, okay, is there any more happies, right? And so it already knows it found its first happy. And it's like the pointer, we'll say, or the placement number is right there. So it goes ahead and searches through and says, oh, hey, look at that. Here's a happy, right? And then the same exact thing. We're looking for any characters. We find a D and then an OGS. And then, hey, here's another one. So we can go ahead and return back happy small dogs. So that's the way the reluctant ones work. Now let's talk about the possessive ones here. Now the possessive works just like the greedy guy, right? And so it finds happy, and then it consumes basically when we tell it for the, this one's 0 or more, right? More times, right? So that basically tells the regex engine, okay, we found happy, and then let's go ahead and go out all the way to the end. Let's eat the whole entire thing for 0 or more, right? Now we're at this, right? Now we need to find the next character, which is a D, and whoops, hey, what's our number one rule that we need to remember? We cannot backtrack. We can never backtrack. So we can't go back and search like a greedy one does. Our pointer's back over here and we'll never backtrack. So guess what? We fail out. We can't find another D past the end of this thing here, So that will basically say no match is found. All right, just to prove the point there, right? Let's take off this dogs on the end and do the same exact reg search here. So regex search. So we do happy. And then, of course, the possessive for 0 or more times, quantifier there, finds happy, and it says happy, and then it says, okay, let's go all the way out to the end, and we're done. We have nothing else to find here. So it takes this whole entire string, including this exclamation mark, and returns that back there, right? Found happy large dogs and happy small dogs, exclamation point. So that's what backtracking is, and that's how this works. So let's just use a few more examples here. And I've got my my little XML things here with one value is yes and another value is no. Now, of course, like I said, you wouldn't use XML tags. Name your tags something else like agree or answer or whatever. But anyway, so we have our greedy quantifier there, and I'm just going to go ahead and move all the XML stuff up to the top here. Excuse me. And of course, this tells it XML, right? Find that tag, right? And then the dot star says, all right, keep on going, eat the rest of it, and now we're going to backtrack until we find this here, right? So it eats the rest of it, and it backtracks and says, oh, hey, look, I found it. Now we're going to check for that /, found that. Let's check for next, found it, found the M, found the L, right? Okay. And then, of course, this final closing chevron there, right? And I found that. So here's my whole entire match. So it returns back all of that when you're talking the greedy one. The reluctant one, of course, just basically says, okay, we're looking for XML, and then everything, and then we're looking for this first character right here, and then we'll start our matching, right? And then it's like, oh, hey, look, I found it, and we're going to match the XML right all the way through there, and bada boom, bada bing. Okay, so you get the idea. All right, the possessive one tells it to go ahead and find XML, and then go ahead and 0 or more, so XML, and then it goes all the way over to the end, and then it's going to look for this opening chevron here, and it's not going to find it because we're at the end of the string and there's nothing else to do, and we can't backtrack. Okay, so we're going to get no matches found for that. We strip that off, we're going to have no problem. XML, consume it all, return it all. Right? So far, so good. Now let's talk about, now I've been doing the 0 or more times one here. Now let's talk about the 1 or more times one here. And it's essentially, in this particular case, is going to function identical there, right? So XML, and then 1 or more, right? So it says, okay, here's my 1. And since this is a wild card, this uppercase Y matches, right? But now the or more causes it to go ahead and eat up the whole rest of the string. And now it's looking for this opening chevron there, and it can't find it. So guess what? No match is found. Once again, excuse me. Strip that off and we're good to go. It'll find the whole entire thing. All right, now what I'm going to do here is go ahead and delete this. I'm going to pause this video here and get a drink of water real quick. Okay, I'm back real quick there. All right, so we've gone over that the once or not at all, the 0 or more times works fine, the 1 or more times works as expected, and the once, I'm going to just undo what I just did, taking all this out. What I'm going to do is leave this up here, and then I'm going to, there we go, that's where I want right there. Okay, so the next thing that we're going to go for is the once or not at all, and that seems pretty straightforward there. So let's just take a look on what happened on that without recompiling that, and we get basically no matches found. And we look at what the engine is doing. It's saying, okay, here's XML, and then we go once or not at all, and then the next character that we're looking for, if it goes to the once, the next character it's looking for is going to be this one here, so it fails out and says it's not found. Now if we strip that off, right, where we're going to have basically XML, and then one character or not at all, it comes out here and says, okay, we got that, and then we have one character or not at all. Well, why did this come back and it say, I'm sorry. Never mind. All right, so we got the no matches up here, right? Sorry, I'm getting ahead of myself here on what I want to talk about next. We got the no matches up here, right? So on this particular one right here, where we don't have anything after the once or not at all possessive quantifier there, it says, okay, this could match here or that, right? Now, remember how I was telling you it was, they're essentially the same thing as greedy, right? Whereas a reluctant one would just basically match this string. The possessive one is going to match this string and that because, it's once or not at all. So it's going to try to return back the greatest possible return on that. And so that's why it returns XML, right? And then our uppercase Y right there. And then when we invoke the find method again on our loop there, it says that it finds one more of them there, right? So it basically had stopped right there and says, okay, I've got my match. I'm good enough, right? It didn't consume the whole entire string because we didn't have we didn't have one of the 0 or more times or one of the 1 or more times. It sees more times that cause it to consume the rest of the string. Now, once or not at all causes it to consume 1 or 0 characters, okay? So it comes over here and finds this one here, and then plus 1 more character is the largest string it can return back, and it returns back in, okay? Now let's come up here and save this, and I'm going to clear the screen, Java C. I'm going to just recompile this real quick here and rerun it real. Yeah, whoop, didn't want to do that. F8. Okay. All right, so taking a look at this one right here, I'm going to show you guys what, when I was creating this, I was kept running across something, and I thought I was doing something wrong in my XML, and maybe I am, but I'm pretty darn sure. I'm almost like 99.9% sure that I'm not. Okay, and I'll show you the reason why here in just a second there. So, this particular line right here is what we want to pay attention to, right? So this is once or not at all. So we should definitely get a return match on this here, right? Let's go ahead and come up here and save this. Let's clear our screen. Run it. Okay, so we get that it found that XML, XML in that particular string. Now, because this is once or not at all, and we can see that in this particular example up here where we have COLO and then U, right? And we're telling U once or not at all, right? We can see that it finds color and is that a coloring book, meaning the U is not in here, right? And it returns that back. So what would happen if, for example, we were to go ahead and take this Y out here, and this is telling it once or not at all, so we got our opening XML tag and our closing XML tag, right? Let's go ahead and save this, and here's where I think I've found a nice little bug in the whole Regex engine on this particular case there. Clear our screen. All right, so you can see now it says no matches found, right, for XML, and then our dot, which is our wild card, and then our once or not at all. And by the way, this documentation is straight from the Oracle website there. And so we get no matches found. Well, that doesn't seem right. And so I was looking at this up here and I'm like going, well, what on earth is going on? All right, so I tried something interesting there, right? We know the dot is a wildcard character there, right? So let's go ahead and come up here and save this, right? Let's clear our screen, recompile, rerun, right? You could see no match is found for COL, and then of course the dot is a wildcard question mark plus for the possessive quantifier there, okay? So I was like, well, that is just super weird. So I went ahead and made another little experiment down here, right? And I said, well, what would happen, for example, if I stuck a U in there instead of the dot? Okay, so I put this back up here, right? So we're going to get our we're going to get our return back result on that there, right? And now all of a sudden, instead of a dot, I just stuck in a U there, and guess what? It found the XML with nothing in there, right? Now our not at all is actually working, and so on and so forth there. So anyway, I thought that was just kind of super interesting there too as well. If we come down here using the same idea with the dot bug there, right? And we're looking for an XML and then basically one character or not at all, right? Let's see what happens with our result now here on this, right? Save that. Let's clear our screen. All right, so you can see it finds it when it's the last one in there, right? That is no problem there. So it found XML in the tag XML, right? But if we change this particular thing to a dot, right, for the wildcard there, come up here, save this, clear our screen, compile, rerun, we get no matches found. So it appears to be just a little buggy thing there for the wildcard symbol combined with the once or not at all there. So, but anyway, Just know that the 0 or more times works just fine, and the 1 or more times works just fine, and these seem to work no problem at all. You know, as a matter of fact, we could probably even try something this, because this is at least x times. So I wonder if we stuck in, well, no, that wouldn't work. Never mind, because that's not the equivalent there. If we put in a 0 here, that would be the same, or no, 0 here, 0 comma, that would be the same as this. If we put a 1 comma, that'd be the same as that. But really, technically, nothing down here is, well, we could do 0 comma 1 actually. 0 comma 1 would be once or not at all. Let's try that real quick there. I'm just babbling on. Yeah, keep watching the video if you're interested, but otherwise, what we're going to do, let's do a 0 comma 1, right? And do a plus on that, and let's see if that finds it with the dot ahead of it there, right? Let's clear our screen. No matches found for 0 comma 1. But now let's just change this to any letter. I'm just going to make this, I don't know, Q, right? Or I better get like a, I don't know, what do I feel like? I feel like a D. Yeah, that's good there. All right, let's save that. Let's clear our screen. And sure enough, so yeah, so it does that same buggy behavior there, does the exact same thing if we use that, or the once or not at all type thing going on here. So very interesting on that. You know, I can tell you if we put a D right back in there, then it'll go ahead and it'll work just fine, right? To match that. And of course we found that. And if we put the star back in there at this point in time, or the dot for the wild card, right? That's going to work too as well. Right? And found that. Okay. Well, anyway, that is the way possessive quantifiers work. I'm going to go ahead and get rid of this, get rid of that. And the one thing to, of course, remember with possessive quantifiers is that they never backtrack. Okay? So that they work just like greedy quantifiers, only they never backtrack. So anyway, that concludes this tutorial. I'm just going to go ahead and get rid of that. Thanks for watching.